मैं proceed नहीं करूँगा। I will prefer to give that side.
हाँ, आप कोई प्रपोज़ करो कोई बुक और if we
आप
have
एक बार
multiple of them, then
earlier you gave the some, remember that you gave once we collected some list of the books, right? From that book, if you want, we can take some book. आप भी
yeah. हाँ, एक्चुअली ये बुक्स जो है ना नई-नई आती रहती हैं, so let's collect the suggestion from everyone and then we can do a quick poll and decide, pick one, right?
okay,
Yeah.
yeah.
We can get started. Shiva, you are starting today,
Yeah,
right?
yes, let me share.
Mhm.
So today, the chapter 17 on reasoning techniques. And I was thinking this is a small chapter because we have already done the chain of thought reasoning, but it seems it's a big one. So I'll start. So basically, these are the advanced reasoning techniques for intelligent agents, and the core principle among all these methods is the allocation of increased computational resources during inference. So rather than a quick single pass, the agent can engage in iterative refinement, explore multiple solution paths, and utilize external tools. This extended processing time during inference often significantly enhances accuracy, coherence, robustness, and especially for complex problems requiring deeper analysis and deliberation. So it states the practical applications and use cases. Some of them we can understand easily: complex question answering, mathematical problem solving, code debugging. I mean, coding, people are using it a lot. And the one thing that I liked about is this self correction, leveraging external inference, inference time for thorough debugging cycles. Then strategic planning, medical diagnosis, articulating its reasoning at each phase, and potentially utilizing external instruments for data retrieval, legal analysis. So these are the following reasoning techniques, and we have already gone through chain of thought many times. So this is the diagram that it breaks down the complex, whatever the user input is, it breaks it down, and then it collects all of them, and then makes a synthesis um, of the steps. So if there is this, you could give a prompt. You are an information retrieval agent. Your goal is to answer the user's question comprehensively and accurately by thinking step by step. So when we say thinking step by step, this is what occurs. Maybe it breaks it down into steps. So analyze the query, formulate search queries, simulate information retrieval, synthesize the information, review and refine. And yeah, so and it gives example also, like user can query, then what would be the agent's thought process, and that's how it proceeds. So the next thing that they are talking about in this chapter is the tree of thought. And I like the tree of thought reasoning technique because it builds upon chain of thought, but it can explore multiple reasoning paths, and then there's I mean, forming a tree structure, which is very clear from the title, but it supports complex problem solving by enable backtracking. So backtracking seems to be important, that it can come back from one of the exploration, and if that exploration had not resulted into a good solution, it can discard. So an exploration of alternative solutions. So maintaining a tree of possibilities allows a model to evaluate various reasoning trajectories before finalizing an answer. So this is uh, the diagram. So self-correction, also known as self-refinement, is a crucial step aspect of an agent's reasoning process. And the critical review enables the agent to identify ambiguities, information gaps, and inaccuracies in its understanding or solutions. This iterative cycle of reviewing and refining allows the agent to adjust its approach, improve response quality, and ensure accuracy and thoroughness before delivering a final output. So, I mean, it's uh, just saying that the same, the prompt is pretty much the same, like the chain of thought. But I think here there is when it tries to give the example how the prompt, how the agent needs to be, like the self-correction agent's thought process. There is a thought three: identify discrepancies, weaknesses, and then that there is a lot of, it can give, we can give a lot of prompts here saying that call to action and concise impact and all that stuff. So this was actually a good example where it had the example was you are a highly critical and detailed oriented self-correction agent. Your task is to review a previously generated piece of content against its original requirements and identify areas for improvement. So here, if you look at how it went, um, it is kind of very nice. It says the user prompt is we have new products, they are green and techy, buy green tech gadgets now. And now the self correction is, it should be short, max how many, announce green tech gadgets. Then again, it has thoughts about what is wrong with it, and it just keeps on. There are lots of thoughts, lots of revised ideas in it, and and then the final uh, output is discover green tech gadgets are new eco-friendly line blends innovation and with sustainability. I mean, this is a small example, but it does give you that it's always thinking that it is respecting the constraints of how many characters, as well as announcing whatever, finding out if there is any discrepancy or it has missed out. So that was good. Then there is this program aided language models, and it is the same that the thought is that LLMs are not very good at math, so actually give it to produce code and then execute it and convert the results into natural language. So that is, those are the coding agents that we have. So this third technique, reasoning technique, fourth technique, the reinforcement learning with verifiable rewards. And while effective, the standard COT prompting used by many LLMs is a somewhat basic approach by reasoning. So the key innovation enabling these models is a training strategy, and this is a post-training and called reinforcement learning from verifiable rewards. By training the model on problems with known correct answers like math or code, it learns through trial and error to generate effective long form reasoning. So, this RAVR has been very important. And, just a few days ago, I received an email which was the state of AI. And this guy actually talks about the DeepSeek moment that had happened on January 2025 with their Argonne paper, and which showed that reasoning like behavior can be developed with RL, and this was a big deal. And the NVIDIA stock had really tanked at that time. So the important about what's so important about DeepSeek Carbon? And RLVR is that they allow us to post-train LLMs on large amounts of data, which makes them a great candidate for improving and unlocking capabilities through scaling compute during post-training. So, and this guy actually talks about the LLM focus points that had been there since ChatGPT came out. 2022 it was RLHF plus PPO, 2023 LoRa at SFT, 2024 mid training, but in 2025 RLVR and GRPO had shined. So he also predicts that 2026 will be about RLVR extensions and more inference time scaling. So let's go back to, we have already learned about React, reasoning and acting many times, and where KB stands for knowledge base. So React agent reasons about actions to take. This is the fifth reasoning technique. So there's a prompt given, React can actually find what action to take, whether to go to a public knowledge database or go to private thought, action, observations, and once the answers are consolidated, it goes back and gives it back to the user. So the loop of thought, action, observation, and then back to thought allows the agent to dynamically adapt its plan and correct errors. So now, this chapter is going deeper into other techniques. There is a chain of debates, is a formal AI framework proposed by Microsoft where multiple diverse models collaborate and argue to solve a problem moving beyond a single AI's chain of thought. So the system operates like an AI council meeting where different models present initial ideas, critique each other's reasoning, and exchange counter arguments. So the primary goal is to enhance accuracy, reduce bias, and improve the overall quality of the final answer. So there have been many agents now. There's deep research, and there is this Stanford had come up with the whole lab, which is just agents talking. There's a council of agents, and they are talking, correcting, critiquing, and coming back with the results. So the whole lab is automated and just run by the agents. So this thing is taking off. There is this graph of debates is an advanced agentic framework that reimagines discussion as a dynamic, non-linear network rather than a simple chain. So this graph of debates is also picking up. Then there's this mass optional advanced. This is an optional advanced topic, and in-depth analysis of the design of multi-agent systems reveals that their effectiveness is critically dependent on both the quality of the prompts used to program individual agents and the topology that dictates their interactions. So the complexity of designing these systems is significant as it involves a vast and intricate search space. So, to address this challenge, a novel framework, multi-agent system search, was developed to automate and optimize design of MAS. MAS is multi-agent systems. So, MAS employs a multi-stage optimization strategy that systematically navigates the complex design space by interleaving prompt and topology optimization. So this is a framework where they actually go through block level prompt optimization. I'm not receiving any feedback. Am I on the? I mean, the pace is good.
Yes, sure. It's
Yeah, it's
very
good.
good.
Okay.
It's good.
All right. Okay. Good.
One question I got with this different reasoning techniques. So these techniques they are looks like more implemented on the side of the LLM, not on the agent side, right? Uh, there
So
will be
if you look at it, what we talk as ChatGPT, Claude, they are not LLMs anymore. They are agents, and sometimes they are multi-agent. So, if last time when we had a discussion, we talked about that, there's the router thing, where once you give the prompt, the Claude or ChatGPT decides which LLM to invoke. All those things are actually kind of an agent uh, framework, not just pure LLM.
Yeah, correct. That makes sense. Like, the LLM is behind the brain, but actually how it is processing, it is like a advanced agent only. And
Yes,
yeah, they are the
yes,
advanced agent. We call them the
yeah,
LLM, but actually they are not. They are just a wrapper around the LLM, but actually they are the advanced agents.
yes, true. Yes, Manoj.
So Shiva, one question. So for chain of thought, they have given this example of prompt where you can specify that this is how you break down a problem, and this is how you sequentially execute it. But
Yeah.
for tree of thought or for backtracking, do you still provide that kind of detailed prompt saying that, oh, these are the multiple options that you can explore, and if this doesn't work, explore other path?
Yes, I think so. I think so, but I think they would also somewhere. I did not see that they are saying that it has to be a tree. Um, in
Okay.
the prompt, they are not saying that it has to be a tree. But in the future, there in this chapter, let's go to this. Um, when they are talking about this mass framework, they have this diagram taken up from this paper, and this paper actually tells about all this, how they are sequencing. So they first do this in the framework itself. They do the prompt optimization, where everything is happening. Like if you look at it, multi-agent debate is also happening. So here they are just doing aggregate and self-reflect, just doing block level prompt optimization. Then in the workflow topology, what kind of topology will be good for this problem? They can go to tree or chain of thought or anything, and then they come up with the optimizer and what would be the workflow. Then after this, that workflow prompt optimization, they have already taken the best topology, and then they evaluate on validation task bit, and after that they come up with the whole optimization. So they've
Okay.
divided it into three parts.
Okay.
So
So basically, all these reasoning techniques is not just driven by the prompt; it's also the capability of the agent framework.
yes, it's also the capability of the, yes, true. Also, what topology it is taking. So it says
Okay.
here a multi-stage optimization strategy is about prompt optimization and the topology optimization. Yes, hi Deepak.
Yeah, hi. So, what I have understood from these two diagrams, right? If we see this,
Yes,
that the chain of thoughts, right? So it means we have uh, split our thing into different operations: step A, then B, then C, then D, above one, above.
yes,
Yeah.
yes, yes, yes,
And then at the end, we actually synthesize all the responses and create a single response. For example, at step A, B, C, and D to Z, we got some responses, and in the end we actually collate all the responses and generate our response. So if we
yes,
see the similar diagram in the case of the tree of that, right?
yes,
So here we are actually uh, doing this dynamic programming sort of thing, right?
yes,
So
yes,
we are evaluating different versions of A1,
yes,
A2, A4. Then among them we choose A star.
yes,
Then from that we again execute multiple steps. So if you see the leftmost thing, it execute A, then execute B, then it actually backtrack to the previous A version, and then finally it has choose the A star. So this
yes,
is how
yes, yes.
that dynamic programming works. So it means
Hmm.
that every step in the chain of thought, we are not evaluating the responses of the every step. We are actually finally collate all the responses. But in the tree of thought, we are actually evaluating whether we are on the right track or not. This is what we are doing in the dynamic programming, right?
Yes, yes,
Means
yes.
matlab,
You're
whenever
right.
we feel that we are on the wrong track, we the backtrack, right? So this is
Yes.
how this works. So and then
Yeah.
finally, when all the steps are ready, A, B, and C, then we collate the best of them, and we got the answer.
Yes.
So I
You're
think
right.
this is
Yeah.
the
Yeah. Thanks
my
for explaining. Yeah, that was the right way. Yes. Yeah. Basically, the same backtracking, dynamic programming that is the software principle. They are using it over here. But I was kind of blown away that they have made this also very complex. Nothing remains simple.
yes. Now the industry is evolving, right? So things will come
Yeah,
like this only. Yeah.
yeah. So yeah, so this workflow topology optimization is like mass employees and influenced weighted method. So in this method calculates the incremental influence of each topology by measuring its performance gain relative to a baseline agent and uses these scores to guide and search towards more promising combinations. So for instance, when optimizing for the MBPP coding task, there must be some coding task. The topology search discovers that a specific hybrid workflow is most effective. So the best found topology is not a simple structure, but a combination of an iterative refinement process with external tool use. Specifically, it consists of one predictor agent that engages in several rounds of reflection with its code being verified by one executor agent that runs the code against test cases. This discovered workflow shows that for coding a structure that combines iterative self reflection with external verification is superior to simpler mass designs. So here it kind of explains what is happening with block level prompt optimization. They're trying to optimize the prompt. There's a self-reflection, there's multi-agent debate, there is tool use. So this is one block of prompt optimization. The second is what kind of workflow or topology is best with that kind of prompt, and it goes and stores evaluation and proposes new workflows. Then eventually it comes with the full workflow prompt optimization. So the multi-agent system search framework is a three-stage optimization process that navigates a search space encompassing optimizable prompts, instructions and demonstrations, and configurable agents, building blocks, aggregate, reflect, debate, summarize, and tool use. The first stage, block level prompt optimization, independently optimizes prompts for each agent module. And the stage two, workflow topology optimization, samples valid system configuration from an influence weighted design space, integrating the optimized prompts. And the final stage, workflow level prompt optimization, involves a second round of prompt optimization for the entire multi-agent system after the optimal workflow from stage 2 has been identified. So workflow level prompt optimization is the final stage and involves a global optimization of the entire system's prompt. And after identifying the best performing topology, the prompts are fine tuned as a single integrated entity to ensure they are tailored for orchestration and that agent interdependencies are optimized. So, as an example, after finding the best topology for the drop dataset, the final optimization stage refines the predictor agent's prompts. And the final optimized prompt is highly detailed, beginning by providing the agent with a summary of the dataset itself, noting its focus on extractive question answering, and numerical information. And then it tells also you are a highly specialized AI tasked with extracting critical numerical information for an urgent news report. So it says as this multifaceted prompt combining meta knowledge, examples, and role playing is tuned specifically for the final workflow to maximize accuracy. So this is the building on a discussion of key reasoning techniques. There is this scaling inference law that say this law states that a model's performance predictably improves as the computational resource allocated to it increases. So there have been many deep research agents in the market in the past year, and Google also has this. This is about ChatGPT. So major platforms in this space includes Perplexity AI, Google's Gemini research capabilities, and OpenAI's advanced function within ChatGPT. So actually, this chapter misses out one very important one was MANUS, MANUS, and NVIDIA has recently come up with a um, agreement that they are going to use the MANUS agents, and those are actually deep research agents. So there's a very simple prompt given to a deep research agent: compare pros and cons of electric cars. And then if you look at it, it says identify the primary environment benefits, research the economic advantage, and explore the performance characteristics, investigate the challenges associated with EVs, analyze the environmental drawbacks, examine the initial purchase cost, research potential concerns regarding battery degradation, compare the safety records. So it has given itself, the AI has given itself so many websites to research, then analyze the results, create report, and then it says it's going to be ready in a few minutes. That's the thinking models that we have. They think for some time. So a fundamental shift introduced by these tools is the change in the search process itself. A standard search provides immediate links, leaving the work of synthesis to you, but deep research operates on a different model. Here you task an AI with a complex query and grant it a time budget, usually a few minutes, and in return for this patience, you receive a detailed report. So there has been always been scaling laws, but here the scaling laws is for the inference. This is the scaling inference law, and there is, but rather employing more sophisticated or resource intensive inference strategies. A prime example of such a strategy is instructing the model to generate multiple potential answers, perhaps through techniques like diverse beam search or self-consistency methods, and then employing a selection mechanism to identify the most optimal path. So they're giving, it says that the cornerstone of this law is the revelation that superior results can frequently be achieved from a comparatively smaller LLM by augmenting the computational investment at inference time. So hands-on code is not much. It's not even it's a proxy code where the builder is saying this is the node generate query, web search, reflection, finalize answer, and it says it is developing a graph. So it says that start with this generate query, but the conditional edge is generate query, continue to web search if a web search is required. So it keeps on adding edges, and that's how it is making um, a graph of a pro search agent. So what do agents think? Again, the same thing: thought, action, and observation. Um, So to guide the agent, the React framework employs few shots learning where the LLM is provided with examples of human-like problem-solving trajectories. These examples demonstrate how to effectively combine thoughts and actions to solve similar tasks. So it's a repetition that methodologies like chain of thought and tree of thought guide LLMs to break down problems and explore multiple solution paths. And self-correction allows for the iterative refinement of answers and ensuring high accuracy. So rule of thumb to use this design pattern is use these reasoning techniques when a problem is too complex for a single pass answer and requires decomposition, multi-step logic, interaction with external data sources and tools, or strategic planning and adaptation. So this is the visual diagram. The key takeaways are like by making their reasoning explicit, agents can formulate transparent multi-step plans. And of course, there's a scaling inference law, which is more like giving it more thinking time. And to build effective teams of agents, frameworks like MAS automate the optimization of how individual agents are instructed and how they interact, ensuring the entire multi-agent system performs optimally. So the conclusion was that an agent's capacity for deep deliberation is fueled by the scaling inference law, where more computational thinking time directly translates into more robust autonomous actions. So there was an appendix also associated with this agent's reasoning engines under the hood, and this was kind of nice that this appendix says that by prompting these LLMs to articulate their own step-by-step reasoning process, we aim to eliminate the fundamental logic that will drive the capabilities and limitations of future intelligent agent systems. So prompt that was given was just standard prompt given to each LLM was, I understand, you can reason. Can you explain me how you reason? Explain me step by step. So, then this prompt was given to Gemini, and everybody says that I have, here it says that I'm a pattern matching thing. So it says my architecture, particularly the transformer model, is excellent at recognizing relationships and patterns between words and ideas. I identify how concepts connect. For instance, I connect reasoning to logic, inference, and problem solving. And it keeps on giving the steps that generating the response, how does it generate response. Then ChatGPT also kind of gives what it does, read and understand the input, activate relevant knowledge, choose a reasoning method, whether it is deduction, induction, causal reasoning, analogical reasoning, and then simulate thinking, which could be chain of thought, and then formulate an answer. And also then after formulating, adjust for clarity and tone. So the Grok also says the same thing pretty much. Contextual analysis and knowledge retrieval, formulating a mental model, and then evaluating options and hypotheses, constructing the response, and review and refinement. So but Grok just says that key characteristics of my reasoning is not only logical structure, probabilistic evaluation, context sensitivity, but also iterative refinement. I refine my output to optimize coherence and conciseness, simulating human self-editing. So then they've given the example of Kimi, that it also says in that reasoning steps, it says identify possible edge cases. So it has given an example. It starts with saying I'm going to give an example question which is larger, 3 to the power of 4 or 4 to the power of 3. And then it gives answers, but here it also says if exponents were huge, direct evaluation would be infeasible and I would switch to logarithms. So, I mean, that also it is known to the LLM or agent. So Claude also says that I have pattern recognition and context building. Then DeepSeek also has the same kind of steps, pretty much. Everybody goes to iterate and refine and apply internal. So the DeepSeek has apply internal training frameworks, techniques learned during RLHF, guide me, be helpful and honest, be clear and instructive, and be safe. I mean, there was a paper that said there is a constitution that is kind of baked into these agents, and that constitution, so they don't stray away from that constitution, and pretty much these are the points that are there: be helpful and honest, be clear and instructive. So those are the things. Yeah, that concludes.
So my general question, like from this appendix system that you showed, so
Yes,
so these information must be taught to the LLM, right? Like if this kind of question comes, like to tell you what strategy you are using, so that means that information already fed it. I mean, like in the technical way, LLM will not know whether I am using transformer model, whether I am using some other model, right? So this must be
yes,
taught to them. So if that kind of question prompt comes, then they will answer these ones. So
yes, yes. So I mean, there has been lots of talks that LLMs is now the old architecture, and even when OpenAI or Anthropic is going to change the base layer, the LLM, we'll not never come to know, because that is the that is the state of things now, that it is agent, and if under the hood an LLM architecture is changed, we are not going to ever find out.
cool. And this all these techniques which I understand from this chapter of decision, it means like if my company is creating some agents, and if they are not using any agentic framework, then we can apply this kind of framework like for complex tasks. So we have to build the code which can like, or ready-made
Yes,
framework, they do provide, okay, pick this option like a chain of thought, which option you want to pick, so the agent work accordingly. So like if somebody has used this kind of techniques, how they consider how they implementation, that's something I am not getting
yes.
very clear idea.
Yes. So, I mean, from my side, the guidance that I would say is don't reinvent the wheel, because things are moving so fast that if in your company people are trying to use these reasoning techniques, it is better to use a framework, because the framework will already have these kind of templates that you can optimize for your company's product or company's use.
Makes sense. Yeah.
Yeah, I haven't prepared. Who has prepared?
Chapter 18 is on me. Right.
Oh,
Okay.
okay.
I mean, like,
Okay, I'll stop presenting.
you guys can see my screen.
Yes.
So, like chapter 18 talk about guardrails or safety patterns. So, in general, like whenever we are doing as software developer, then like we have to create a secure software developer. All our systems should be secure. There should not be like unauthorized use of our systems, that kind of thing. Everybody know in the security, what is security all about? Like security talks about confidentiality, integrity, and availability. So confidentiality means like your data should be confidential, and integrity means your data should not be manipulated by somehow, and availability in the sense like your system should not be like broke down. You know, like how the denial service attacks works, like where your website brings down, like these many people like the attackers, they bombard your site with lots of requests. So that kind of thing. So same kind of concept like developing secure agent, and then we have to think about like, okay, we are developing an agent, then what the risk, what's the threat that we will lead to these systems, right? So when we say the thing in general like AI agent, we know agent is using the LLM, and we know the LLM is very probabilistic. So and then they can generate unpredictable output to your questions or whatever you ask to do, whatever prompt you are sending. So now you want to make that control, like, so you want to make your system should be like behave in such a way that you can say, okay, the answer coming from your LLM should be safe, and you know, like they will not give you some unreliable answer. So that's what something we expect from a system for a in general in a security mindset, or the, I will say, risk mindset. When you are, because whenever you are put something, any software into the out in the internet, you everybody think, oh, whether it's secure or not, whether my data is safe or not. So those kind of questions come. So they are how. So to make that trust on your AI agent, how you explain to people, oh, your software is like trustworthy. Then they will explain you like, okay, we are using this kind of like a secure techniques to make sure our software is safe. So now those secure techniques, what you explain, then this comes like what the secure techniques using. Then that secure technique, the name gives in the AI word like a guardrails, or we call it safety pattern. So in general, this is why we are talking about guardrails and security safety patterns in AI system. So as I say, like we want a responsible AI, like they say your AI agent should behave as intended and ethically and safely. This is the whole purpose of the guardrails and guardrails into the agents. And you like in general again, like in any software development, like how you make system like safe. So whenever any input coming to in your software, you want to make sure that input is like valid. It is like whitelisted or blacklisted kind of stuff. So similar kind of in general software security principle applies to when you are building the AI agent. So because there is input, there is output. So you have to make sure your input is validated, sanitized, and the output that you are sending, again, you have to make them like it is sanitized and it is validated. You are not sending any bad output to your user. And again, like we know, like in software, we do the auditing, we do the compliance check based on your business domain, like so know the, like your system is working as intended. So these kind of all the things that policy, security policy, compliance process, they all can be implemented through the safety pattern or guardrails into your AI in your AI agentic capabilities. Now, what I understand, like when you are implementing the guardrails or your safety process into your when you are developing the agents, they all depends based on your use cases. You cannot create one guardrail that generic guardrails like input validation can be applied to the all like prompt sanitization can be applied to all the use cases, but they gonna be like more particular safety process as per your AI agent use case. So it says customer service chatbots. So chatbots, like we know, like it can LLM can spit out toxic materials. So we have to make sure like whenever the response is coming from the LLM, it doesn't contain toxic output. Like just now, recently the news came like on Twitter, like from India, they're putting some images generated which are very obscene. So those kind of content moderation is not done on those outputs. So that means we need their guardrails so which can verify. So how they gonna Twitter gonna like Meta gonna fix that problem? So definitely they're gonna put a guardrail which will say, okay, if any that kind of image is generated by their system, they have to check for the any particular rules like is not obscene or whatever. Like so, those kind of like so many rules. What can be happen on those content generation? They have to put some kind of guardrails there. Guardrails in the sense like some kind of either it could be some in a technical solution. It could be like checking the image validity by some third party solution, or I don't know how the people do the checking whether the image is obscene or not. There should be some way that's kind of like a verification they have to put into the system.
There might be the kind of request that can be checked. What kind of request is coming and what is the content or the words used in the request.
Yeah. So again, those kind of technicalities, they are all I would say like very domain specific. For text, we know like we can search for some bad words into the content, right? So that kind of like regress related pattern, or maybe using some third party system which where you give your response and put the response, you let them tell whether this contains some any toxicity. So all this kind of like implementation, they come under the guardrails pattern, safety pattern, how you're going to do that, correct? Like in a standard normal web application, like you set up like we have firewalls, right? So the web application firewalls will check like whatever the page request coming to your website, they will check whether it's not containing like any injection related stuff like XSS or SQL injection kind of thing. So same kind of firewall or guard, they are calling it a guard, they are not calling firewall. So it's the same kind of concept in a standard like only generic security need. So again, like for me, like if you want to understand more about guardrails, then you should be expert in your system, like what my system is doing, like it's a business requirement, like your so for content generation, like it should not contain hate speech. For education, like if the student asking any question and say like, oh, what is the capital of India, it should not say like, no, we say Delhi. So that kind of verification who gonna do? So you need guardrails so that to validate the answer is coming right or not. Same for the legal research. I don't know like what the legal people do, like they are quoting some kind of previous judgment, then they should know like whether the judgment was related to your context or not. So and again, so I think in general you can understand like it's like a business problem. I will say what the risk you are solving here, what the threat you can perceive from your system, that you have to think through it very properly, and then those checks you have to put into your whenever you are generating the response from your agent. So if you directly go to I mean like there is nothing like very specific like God is what they are doing. Your prompt is coming, then you are doing the input validation, sanitization. Means like there is also AI involved here, like your prompt checking like your prompt is not containing some kind of question which is like it should not be answered. That it's still the prompt is still not containing any hate words or anything. Hate words is just one example. So that kind of check is happens here. Or you are not your agent is not asked about to execute or perform some action which should not be allowed. So that kind of like check you perform here, then your once that check is passed, your prompt say, oh yeah, your prompt is safe to use, then your actual prompt is gonna pass to your actual AI, your core AI, which is gonna do the actual work. And then once that work is performed, then your again that output should be again revalidated because you don't trust what your AI is also safe or not. So you have to again check whether the answer coming from that is it good enough. If it's trustworthy, is reliable, then you can send that answer to your user. Else you do again rechecking. Or if you don't understand, then okay, you are still not sure, then you maybe throw the error and say, okay, we are not able to get the right answer. So that kind of or you will involve some kind of like a human in the loop, a person who manually say, okay, this response is correct, so it should be passed to the user. So that kind of technical implementation should be done in this way. So standard how you do the security in a software development. And again, then when you are thinking about guardrails, the guardrails we are developing, then we have to think the security as a whole of the software system. Like there is some security principle that we have to follow, like least privilege principle. Like your agent should not be doing more than what it's supposed to do. So it should have the right it should have the tool access. And that tool should be like a limited, like define your business rules, like whether this, like for example, if you are doing a code review agent, you are doing, then the agent should be able to access some repository, code repository, which is very highly sensitive. So that kind of your agent should allow to access that code repo. So now who gonna put access check on that one? So you have to put some check there, like if the request coming to this repo, your agent should know, okay, I am not allowed to access this repo. Please, it will say, okay, access denied for I cannot access that code. So if you think through that kind of scenario, then you will say, okay, yeah, they are how we have to put the check into our system, and they are the guardrails and the patterns. And same thing like yeah.
I wanted to tell so there is this diagram where it says it actually sanitizes the prompt, input validation and sanitization before it gives to the agent. There was one of the incidents in which there was a jailbreak, and that jailbreak was an image was provided, and it was an empty image. To the user, it looked like an empty image, but it was white on white written for the jailbreak, or give an example of bomb making, and actually the LLM went ahead and gave the answer because it had not checked that this I mean, for user it looked like it is just an empty image, but the LLM could see the instruction written in it.
Like same thing, like people are talking about, like if you are sometimes you generate the code from the LLM, the code is generated while you are seeing some text, but there are also some hidden code that you cannot see, your editor cannot read it. And when you run that code into your system, maybe it like it's kind of malware, like your system is like you got virus in your system. You click some kind of file which you don't know. So
yeah, I mean, this has a lot of access, isn't it? The prompt, we are doing so much prompting, making templates. There's a lot of ways to go. Things can go wrong.
So you have to. So for guardrail perspective, you have to think through the risk and threat. What can go wrong? If you can think through that correctly, then you will start implementing your safety patterns in your system, and that's what the guardrail I understand. Okay. And
yeah.
Okay, yeah. So again, like I will go through the again like a process wise, like when you are developing guardrails, then you have to keep your separation, like generic secure software principles, separation concerns, like you have to follow this pattern. Like if you're like say if one code agent is have access to data, then it should just have to access data. One agent can access the code, then it should have access to the code only. It should not go more than that. So that kind of like this security separation concern you can implement in the system, and then you can secure each agent accordingly. And observability through structure logging, same generic principle, like you have to log your actions. Agents generate the actions of what tool they are calling, then so that you can analyze them and you can find out if some agent is trying to access some tools which is not supposed to, then you know, okay, this is happening, or what kind of error is happening. Somebody trying to get into your system and trying to execute some action which is failing. So you know, like, okay, we have to put some kind of restriction in your system to make it more robust. Again, I already talked about principal least privilege. So give only the minimum access. Then from that, you evolve your system, like, okay, this agent abstraction, then you will put some more access to that, so that you're not providing by default like access your system, and it is open for your attack surface. Then hackers, they figured out how to get into your other system, or how to manipulate your agents to retrieve some kind of data, or do some malicious activity they're supposed not to do. Okay. So yeah, I will stop here on this one. Maybe the next time we will go through the code. Just that will give you a basic example, like how the guard is in actual, like how you implement actually in a technical way the guardrails. So we can, I think we cannot complete the code in this session. So I will pick up next time. Okay. Yeah, I will stop here. Other thing I think I already have talked through, like they are all talk. Simple. secret software principle, if you understand, then you say, okay, same thing apply here.